Good evening, Titans. And I know you're all hoping for a snow day tomorrow, and it might happen, but just in case it doesn't, make sure you're prepared for section 9.6, factoring special polynomials. We're first going to look at perfect square trinomial. And for something to be a perfect square trinomial, it must pass these three rules. So, the first thing is that the first term of a perfect square trinomial must be a perfect square itself. So for example, 4x squared. 4x squared is a perfect square because it's 2x times 2x. And then the last term must be a perfect square. So I'm just going to write down plus 9. Now, it must be a plus 9 for it to be a perfect square because again, remember, a number multiplied by itself is a perfect square. So 3 times 3. Now it could also be negative 3 times negative 3, which is why it has to be plus 9. And then the middle term has to be twice or 2 times the product of the square roots of these terms. So 2x times 3 is 6x. And I have to take that times 2, and that would have to be 12x. And now this would be considered a perfect square trinomial. So let's take a look. First, this is just the algebraic rule for what perfect square trinomials look like. And again, if it is a perfect square trinomial, then it can factor into a binomial squared, or two identical binomials being multiplied times each other. Now, if the middle term's a minus, then the sign between the terms in the binomials must be minus as well, and you can write it as a minus b quantity squared. So here's the first example. So again, we must first see, does it pass the three rules? Well, is 16x squared a perfect square? Well, sure, it's 4x times 4x. Is 1 a perfect square? Yep, 1 times 1 equals 1. So now we have to determine, is the middle term 2 times the square root of the first and the square root of the last, which that would be 8x, and that's what that is. So it is a perfect square trinomial, which means now it factors into 4x plus 1 quantity squared. And again, if we write this down twice, 4x plus 1 times 4x plus 1, and we FOIL it, there's your 16x squared. 4x and 4x is your 8x, and 1 times 1 is 1. So we're not going to really worry about factoring these. We just want to see, are they perfect square trinomials? Well, x squared is a perfect square. 16 is a perfect square. And so x times 4 times 2, that has to equal 8x. And since the middle term equals 8x, that's a perfect square trinomial. Now, is this first term a perfect square? Well, no. 3 is not a perfect square. So this is not a perfect square trinomial. This is a perfect square. 9 is a perfect square. So I have x times 3. Then I have to take that times 2, and that equals 6x. And so the middle term has to be equal to 6x for that to be a perfect square. And since it's only 3x, then this is also not a perfect square trinomial. Now let's look at factor perfect square trinomials. So these are all perfect square trinomials. So we're not going to worry about really having to determine if they are. So this first term is a perfect square. The last term is a perfect square. And then since the middle term is minus, this has to be minus. Now, we could write it down twice like this. And again, when you do that, it does make sense that that middle term, negative 5x is your 10x. But remember, we can write it as x minus 5 quantity squared as well. Now, if we take a look at this next one, we have 49y to the fourth plus 14y squared plus 1. Well, 49 is a perfect square because 7 times 7 is 49. And then how do I get y to the fourth? Well, y squared times y squared. So there's that perfect square term, and it's squared, right? And then 1 would be plus 1. Now again, if I take these two terms, multiply them times each other, and then take it times 2, that has to equal that term. Well, 7 times 1 is 7 times 2 is 14. So now that factors into 7y squared plus 1 quantity squared. The third one here, 9x squared. Well, that's a perfect square of 3x. 16 is a perfect square of 4. And since this middle term was a plus, I know my sign between has to be plus, and quantity squared. And if we check, again, the rule is take 2 times 3x times 4, and if that's 24x, which is what it is, then that's the right factoring. And this last one, again, we have one here with the fourth, so I have 8a squared, because 64, the square of that is 8. B squared would just be b. Now, because this middle term is minus, it's going to be minus here, quantity squared. And again, the check to make sure the middle term's right is 2 times 8a squared times b has to equal 16a squared b, and it does, so it checks. And that's factoring perfect square trinomials. Pretty simple. We have to look for a pattern, and again, its most important part is to look at your first term and your last term. And if those are perfect squares, then usually you're probably dealing with a perfect square trinomial. The next type we're going to discuss are called differences of two squares. And so, if we definition of this and rule, it's two perfect squares being subtracted. And if they are, then it factors into two binomials where one of them is a sum and the other a difference. So, we look at this first example. 1, it's a difference, so that's difference of two squares. That's the first part. Then 100n squared is a perfect square because the square root of that is 10n. 9 is a perfect square because 3 times 3 is 9. And so now I have my terms, so I'm ready to plug into my binomials, 10n minus 3 and 10n plus 3. And again, notice when I do that the outsides and insides, this 30n and this is negative 30n, cancel each other out. And so these are the two binomials that multiply to give me the differences of those two perfect squares. Again, we're just going to look to determine, are these perfect differences of two squares? And this is a perfect square, this is a perfect square, and it is a difference, so yes, that's a difference of two perfect squares. Here, 15 is not a perfect square, so this is not a difference of two perfect squares. And this last one, is this a difference? Well, I don't think so. Looks like a plus sign to me, so again, this would be not a perfect square. So, if you want to try these on your own, go ahead and pause it and try it. Or watch me work one or two of them and then try the last two on your own. So this first one is, again, a difference of two perfect squares. So it's going to be x minus 2 times x plus 2. And again, I have to write both binomials because the binomials are different. One is a difference and one is a sum. And that's how the middle term is taken away. In this next example, it would be 6a minus 7b times 6a plus 7b. So 25, 5w, and then minus 9, and 5w plus 9. And again, it doesn't matter if you put the difference binomial first or the sum binomial first. And then this last one, m squared minus 121. Well, m squared is m and m. 121 is 11 and 11. And again, one of these must be a sum and one of them a difference, and it checks. All right, so that concludes special polynomials. and be ready to get after it the next time we see you. As I said, we might have a snow day. You know, if you wear your pajamas inside out and backwards and get up at 2 o'clock in the morning to flush the toilet 3 times, my kid says it's guaranteed. So, give it your best shot, and if not, we'll see you tomorrow. Good evening.
Made with Doodlecast Pro.